this video will cover section 4.3, part 2. We're going to start with the last class. We went over the 6 trigonometric functions or trigonometric ratios, which are here on this table. So we have sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. And of course, we have cosecant is the reciprocal of sine. Secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So now let's go ahead and apply those rules with triangles, okay? So we're gonna step out of the unit circle for a minute, but then we're gonna go back to it so that we can complete filling it out, all right? So we have here the angle in question is angle theta, which is there. And so we're told to find the value of each of the 6 trigonometric functions. And of course, we already know that they are sine, cosine, and tangent. And so sine, of course, it is opposite over adjacent. I'm sorry, opposite over hypotenuse. I should probably write it down. So that is equal to 5 over c. Now, we don't know what the hypotenuse is equal to. However, we are very familiar with the Pythagorean Theorem, right? And so that will be c squared is equal to a squared plus b squared. And so if we want to solve for c, that will be the square root of a squared plus b squared. In this case, we are talking about a triangle, so we want to get the distance, so we will only be getting, of course, a positive square root. So in this case, a is equal to 5, so 5 squared plus b is equal to 12, so 12 squared, and that will give us c is equal to 25 plus 144, and oops, I'll continue here, I guess. So c is equal to 100, the square root of 169, which is equal to 13. And so here the hypotenuse has a value of 13. Now we can answer the question here. Sine is 5 over 13. Now cosine is adjacent over hypotenuse. So remember, the adjacent side is that side that is actually forming the angle. All right, so that will be the adjacent side, and that is 12. The hypotenuse is equal to 13. Now for tangent, we don't need to divide sine over cosine anymore. We can simply divide the opposite side over the adjacent side. And so the opposite side, of course, is this one, 5, opposite to angle theta. And the adjacent side is 12. Now we have the first 3. We can get the reciprocals of all of those. So could you guys try to get those, please? So you will get for cosecant, the reciprocal of sine, for secant, the reciprocal of cosine, and for cotangent, the reciprocal of tangent. Okay, so Sine, what is the cosecant of theta? Not over 12, over 5. And remember, cosecant is defined as hypotenuse divided by the opposite, so let's just make sure. Hypotenuse divided by opposite. Okay, for secant, Karina, what do you got? 13 over 12. Yeah, 13 over 12. And then Brandon for cotangent. Figure. So we are going to need the reciprocal of 12 over 5. All right. Now I want you guys to do the next one, but you will find the 6 trigonometric ratios. But before that, let's just go ahead and figure out what does b equal to. Okay. Now if we were to start with the Pythagorean Theorem, which is a squared plus b squared is equal to c squared, and we want to solve for b in this case. So b squared will be equal to c squared, and of course this positive a squared, it is adding, so if we take it across, it will be subtracting. So a c squared minus a squared. And so b will be the square root of c squared minus a squared. And I just want to point out that this is one of the most common mistakes that I see sometimes on exams. When you are trying to find c on a right triangle, the hypotenuse, you must do the square root of the addition of a squared plus b squared. But when you are trying to find one of the sides, whether it's a or b, you're going to be subtracting the, it will be the square root of the difference between c squared and a squared. So please, when you take the exam, be very conscious about that, okay? If you need to add or subtract. Are you finding the hypotenuse or are you finding one of the sides, all right? So you guys could work, within your group. Cecilia, if you want to move on, or you just like being there? Okay. If you want to move to a table, that's fine. Or if you guys want to move back over there, or you guys move there, whatever.
Limit 7, so it's only like addition when you're finding the hypotenuse.
Correct. Yes. So here, this will always be add, and then to find a side, subtract. Yes, and that would be the same if we were to find a. Okay, so I'm going to be pausing the video while you guys work. So anytime we say find the 6 trigonometric functions, that's what we're talking about. Sine, cosine, tangent, secant, cosecant, secant, and cotangent. For B, is that the question? I want to point something out here, guys. We're going to be using exact answers, so we don't need any decimals. So, do you guys get the square root of 8 for B? Okay. So, we're going to simplify it by doing the following. We're going to get 2 factors of 8, where one of them is a perfect square, such as 4, right? Because you could take the square root of 4. Now, if I take that expression is equivalent to this one, the product of the square root of 4 times the square root of 2. And of course, to get the square root of 4, we can get that as a 2. And so the 2 comes out of the radical. And however, this square root of 2, the 2 will remain inside because that is an irrational number, no exact solution. So that will be the value that we're actually going to be using for B. We're going to be using 2 times the square root of 2 instead of the square root of 8. All right? Now, on the exam, I'm actually pretty cool about that. And if you feel like you're going to do that wrong, the square root of 8, and you're not going to get the equivalent expression, I still give you credit if you use the square root of 8. I'm okay with that. So I'm going to, let's check to see if we have the same answer. So for sine, you should have something like 1 over 3. Yes? Okay, so cosecant will be what? 3. Or 3 over 1. For cosine, you should have 2 times the square root of 2 over 3. So now for secant, it's going to take us a little bit of work, so it will be 3 divided by 2 times the square root of 2. Now here we need to rationalize the denominator. And in case you're wondering, do I need to multiply by the whole denominator? No, you only need to multiply by the square root of 2, top and bottom. So this will give me 3 times the square root of 2 over, and now what's going to happen here is that we have this 2 here, and then once we multiply the 2 square roots here, It's like we're squaring the square root of 2, right? So the square cancels the square root, so therefore it's 2. But those two numbers, this number is coming from here, okay? Those two numbers are still multiplying. So in reality, the denominator should be what number? What is 2 times 2? 4. So that is the answer for the secant. For tangent, we have opposite over adjacent. We rationalize, but only multiply by the square root of 2. Now, my math lab, it is very picky about this simplification. So if you were to use the square root of 8 for b, it will probably count it wrong. Sorry about that. On the exam, I'm okay with that. So here, after we rationalize the denominator, we should have square root of 2 over 4. Yes. And why is it 4? Because we will have 2 times 2, right? That's what gives us the 4. All right, now for cotangent, I'm going to get the reciprocal of tangent, but I'm going to get smart and use this one, right? Before we rationalize. And so that will be 2 times the square root of 2. And that's all. So that's how you get the 6 trigonometric values using triangles, all right? Right triangles. So let's go now to the next slide. Now I'm going to use the special right triangles. You guys take a geometry. Have you covered special right triangles? The ones who took it last year, you did for sure. But the ones now, not yet? No? Okay. So there are 2 special right triangles. Well, actually, yes, 2. One of them is an isosceles right triangle where this side is equal to this side. I know my drawing is not perfect, but just use your imagination. And so if that is the case, if those 2 sides are congruent, then the angles, this one and this one, are also congruent, right? That is a characteristic of an isosceles triangle. 2 sides are congruent, 2 angles are congruent. So if the sum of interior angles of a triangle is 180, correct? Yes? 180. So we have 180 degrees. We're using 90 here. So how many degrees do we have left to spare? 90. And we have to divide them into 2 equal quantities. So that means that this angle equals what? 45 and 45. And so that is one of the special right triangles, all right? So in general, the rule is that if this side is x and this side is also x, the hypotenuse is going to be 2 times, the square root of 2 times x. So if these 2 sides were, let's say, 10 each side, then the hypotenuse will be 10 times the square root of 2. If these 2 sides were, let's say, 4 and 4, then the hypotenuse will be 4 times the square root of 2. Now, we have here the same special right triangle, isosceles right triangle. And so here the sides are equal to 1 and 1. So that is the value for x, right, according to my drawing here. So then it makes sense that the hypotenuse is actually 1 times the square root of 2, or simply the square root of 2. Yeah, are we okay with that? All right, so now we're going to find the trigonometric values, and we already know them, right? Do we? That's where the sine and the cosine are the same. By the way, 45 degrees in radians is pi over 4. Does that sound a little familiar? No? All right, guys. So the sine, does anyone remember? What is the sine? Okay, let's try to do it with a triangle. So the sine of 45 will be opposite over hypotenuse. So it will be 1 over the square root of 2. We need to rationalize. So that will be the square root of 2 over 2. All right. Cosine. Look at the drawing. So the cosine is the adjacent side over hypotenuse. So that will be 1 over the square root of 2. Again, we rationalize. And we get the square root of 2 over 2. Tangent, it is opposite over adjacent. 1 over 1. And that equals 1. Now I want you guys to find the remaining 3 by finding the reciprocals of sine, cosine, and tangent. And I will suggest that you use this form of sine and this form of cosine to make your life easier. So when I say reciprocal, we all know what you need to do, right? Okay, so Annette, what do you get for cosecant?
Square root of 2.
Square root of 2, very good. Brisa, what do you get for secant?
Square root of 2.
Okay. And Samantha, what do you get for cotangent? All right. Now, I believe we already have those on our unit circle, right? The ones for pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay. So now let's look at the other special right triangle. And so the special right triangle here is actually going to be the so that would be the triangle with angle measurements 60, 90, and 30. So let me show you first from this image on the left how we get to those measurements, to the rule, okay? And you will see this in geometry when you get to special right triangles. So we have, if we consider the whole triangle, of course, we have a triangle where all sides are equal, okay? So this side, we call those triangles equilateral triangles, correct? All the sides are equal. So if all the sides are equal, that means that all the angles, interior angles, are also equal. So this is 60, 60, and 60. Now, if we trace an angle bisector or a perpendicular bisector that cuts this angle exactly in half, then this half of the angle will be 30, correct? Yes? And of course, if this is a perpendicular bisector, that must be a 90-degree angle, correct? Because it intercepts, it does not intercept. It forms a 90-degree angle with the base of the triangle, the perpendicular bisector. So now, what I'm doing is cutting this equilateral triangle in half. So I'm just going to take the triangle that is in green, all right? And, or the one on blue on the right side. We will use that one in a minute. So the idea here, when we started with the equilateral triangle, was that each side was equal to 2. This side was 2, this side was 2, and this side, before we cut it, was 2. Now, the perpendicular bisector is not just cutting the angle in half, but it's also cutting the base in half. So what is half of 2? It's 1, right? So that's how we get this 1 here. So now I'm going to move on to this other triangle here on the right side. So here, this is a 1, and this is a 2. Because that's how we started constructing our equilateral triangle, with each side equal to 2. So now let's use Pythagorean Theorem to see why this one is the square root of 3. Okay? So we have, let's say this is C. Let's call this one A. And so we're going to be looking for B. So you might want to do this on the side of your paper. So B, let me do the whole thing again. So we start with A squared plus B squared is equal to C squared. So then B squared is going to be equal to C squared minus A squared. Please remember that part, okay? You're subtracting BA squared. So B is the square root of C squared minus A squared. Now let's go ahead and substitute our numbers here. So B will be equal to the square root. C squared is 2, so 2 squared minus 1 squared. And so that will be 4 minus 1, which is equal to the square root of 3. And so that's how we get that this side is the square root of 3. You could also see it here, of course. Now, as a general rule, when you study this in geometry, this is the rule for that triangle. So if we have 90, 60, and 30 triangle, the rule will be that this will be x, this will be 2x, and the hypotenuse will be 2 times the smallest side, and the remaining side will be the square root of 3 times x, or x times the square root of 3. Since our triangle, this is something that you could use all the time, okay? It might be like a problem on ACT, SAT. They love special right triangles, just so you know. So in this case, our x was equal to 1. Our hypotenuse was 2 times x, so 2 times 1 is 2. And our remaining side was x times the square root of 3, so that was 1 times the square root of 3. Okay? All right. Now let's go ahead and use this blue triangle, okay, to find the sine of 60. So sine of 60, we want the side that is opposite to this angle. That would be the square root of 3, correct? And the hypotenuse is 2. And now what I want you guys to do by yourself, I want you to find the cosine of 30. The last one on that list of 4. Cosine of 30. So you need the adjacent side to 30. Remember, the adjacent side to 30 should be one of the sides forming the angle. Adjacent side to 30. Okay, are we getting the same?
Yes.
Isn't it weird? Not at all. It's not weird. Okay? So think about it. Whatever is the opposite side of 60 is the adjacent side of 30. So that is always going to happen. And so anytime you have complementary angles, such as 30 degrees and 60 degrees, or 45 degrees, and what is the complement of 45? 45. Then what's going to happen is that whatever is the sine of those angles is going to be the same as the cosine of the complement. Those are called cofunction identities, and those are coming up, okay? Similarly, whatever is the cosine of this angle will be the sine of this angle. Let's see if it's true. Let's do one more. So I want you guys to find the cosine of 60. So cosine is adjacent, so we need the side adjacent to 60. So that will be 1. Hypotenuse 2. And then go ahead and find the sine of 30. Sine is opposite, but now we're talking about opposite to this angle. And that is 1. Hypotenuse is 2. All right, so those are not a coincidence. They're called co-function identities. Okay, so let's go to the next slide, guys. And we have here a table that, you know how I keep insisting you are going to memorize all of this. It's not a huge deal. You can do it, okay? There's several ways you can remember. I'm going to teach you one. If you line up your angles by smaller to greatest, and we call this our special angles. Those are the ones that we have on the unit circle on the first quadrant, right? So if you line them up in the small to largest, and you do the following. You have the square root of 1, square root of 2, square root of 3. On the bottom, this is what I mean. Square root of 1, square root of 2, square root of 3. On the bottom, they all have 2's. You guys notice? Now this one, what is the square root of 1? Just 1, so it's 1/2. Now, if that is the case for sine, then for cosine, will be in reverse. So it will be the square root of 1 over 2, the square root of 2 over 2, and the square root of 3 over 2. And of course, this one we know it reduces to 1/2. All right? You could also make the connection that whatever is the sine of 30 is also going to be the cosine of 60. Yes? Okay. So now I want us to go to the unit circle. So I don't even remember how I got that orange. I'm going to apologize in advance, but I'm going to ask you guys to watch the rest of this video, okay? Because I really cannot get behind since Ms. Salazar and I need to be at the same pace. The unit circle. Okay, so now remember that we're doing cosine goes first. That's the x, and sine is the y. Yes? Are we on the same page? So sine of 30, that's my favorite. I always remember that one is 1/2. And I'm actually going to be quizzing you. Every time I see you outside, I'm going to ask you some of those randomly. Sine of 30 is 1/2. The cosine is the square root of 3 over 2. So now let's reflect this point here across the y-axis. So we know the x-coordinate is going to change, so that will be negative square root of 3 over 2. The y-coordinate is still 1/2. Now if we take that same point, the original point, to quadrant 3, both the x and y will be negative. So negative square root of 3 over 2, negative 1/2. Both x and y negatives. If we take it to quadrant 4, the original point, the x is still positive, but now the y is negative. And now let's work with 60 degrees, or pi over 3. So remember how the sine and cosine were inverted, right, or interchanged? So we could do that. Cosine is 1/2. And the sine is the square root of 3 over 2. We take that point and reflect it to across the y-axis. So now the x is negative. So negative 1/2 square root of 3 over 2. If we take that original point to quadrant 4, that will be, both of them are negative. So it's negative 1/2 for cosine, and negative square root of 3 over 2 for sine. The original point in quadrant 4, Now the x is the same, so positive 1/2. The y is negative, so negative square root of 3/2. Okay, so what I really want to let you know, of course, these 4 points are very important that you know them, but I think that anyone in Algebra 1 knows that, right? How to plot those points. If you guys can memorize what's happening on this first quadrant here, you're good to go, because you will be able to find any other trigonometric value. All right? So I'm going to stop. I'm going to let you guys go because it's time, but I'm going to finish recording this video. All right? And I really, really need you guys to watch it.
And for the,
Yes.
for the last, we don't come